Okay, so I will skip the introduction because I told you about ACCA and usBIM and also myself. And I will just jump straight to the examples. So this is the Hello World example. And it's basically the one that you have already seen from the IFC5 course. Okay, so basically this one you have maybe probably already seen in the introductory course. It is the first file that you will find out. It's just a wall with the two windows, with all of the details of the structure. But already we can see something not new, but different from the previous version of the standard, which is the space boundary representation. So there is the space and the boundary also with the geometrical information. So definitely something that we want to keep in mind, because some of the entities that maybe were not so much used in the previous version of the standard, now maybe they have more value. And if you followed the updated course, you will already also had seen this example, which is basically an example that shows how easy it is to compose a scene. What does it mean? It shows how, with few lines of codes, we can transform the previous wall into a layered one, and also how we can easily add a second floor to the building, and also how to attach information on the geometric objects. In particular, we have a material that is attached to the geometry, and related to the material, we have the properties. This is something that material properties also have been discussed about in previous version of the standard and not very often fully supported. And now they get a different place, so they should be used more naturally. Linear placement, all the efforts done in the IFC 4.3 standard are now captured both from the semantic definition of it and also from the geometric one. So all the things about IFC 4.3 are still there, including the station of the object, the linear placement, which is still in discussion, but also the alignment, its business logic, its structure into the horizontal, vertical, and cant alignment, with all the details about the parameters, such as, for example, the radius of the curves and so on. They are being kept as they are defined in the IFC 4.3 standard, just defined with this new data structure of the IFC5. And here we just start to see something new. PBR materials, they IFC, the previous version, does not love textures very much, but not also the PBR materials. In this case, we see how the information of GLTF, which is another standard, is bring into the IFC model, so that we have such information, which means that application that supports it, like usBIM in this case, can show it with all the reflection, metallic roughness, and so on. And this is just an important example, not only because of the material itself, but because it's the first time that we reference another standard from the IFC. And in particular is the GLTF, the definition of the PBR materials. So this is definitely something that should start to we should start to think about. And of course, following this, we expect also texture to be implemented in a similar fashion. This is another example. By the way, this is made by Bedrock company. The previous one so far were all from buildingSMART International, and we have a geotech examples. Here again we have a composition, so different models are coming together, and in particular we are again referencing an external standard. So we have the definition of the properties that we want to have, and then on the object of the model we have the actual values, in this case for the geotech information. So again, we are referencing an external existing standard and bringing it into the IFC files, but I will say rather models. Going forward, this is another example from POR Romania, which shows phases of tunnel excavation. Now you can think that the geometry is quite simple, so they are not quite complex models, but still shows the special structure subdivision of how a tunnel is excavated. So from the top, the small pieces, and then there is the middle part and the bottom of it. Again, not much detailed from a geometric point of view, but there is a lot of data and reasoning involved about this example. And also the fact that that does not come directly from BSI is a good sign, because it means that also others are contributing to it. This other one is from Edificios, which is a BIM authoring tool from ACCA software. We started implementing an alpha version of an IFC5 export, and basically is just our example building from the application as exported in IFC5. So again, we started with the implementation of the export functionality, but this probably will be changed a lot going forward, but still shows the support that we try, the effort that we try to make to support IFC5. Then we have an example from SketchUp from Trimble. This is Barcelona Pavilion. Basically, they modeled it and made it available for others to import for the ESRI conference in August. And I will say that SketchUp is one of the most active in trying to implement this standard as well. So another software vendor supporting all of these. And this one is done by OnTrack, is also the example done from buildingSMART for the certification, is a composition of different models. It's a simple one, but there is something about bridges, something about roads, rails, a little bit of architectural part, and then all those models are coming together into a single federated scene. For this one in particular, bonus points because they use also bSDD classification attached to the apples of the tree using one of the first classification done for example of the bSDD, which is the fruit and vegetables. So they are using simple stuff, but showing all the potential. Not only buildings and infrastructure, but also the structural part coming into play. This one is from Tekla Structures, which shows also how they are start supporting IFC5 with the export of a structural model. Since there is not yet definition about the structural data, it's mostly geometric, but we can already see the geometric level of detail very high, and so we expect then the actual data attached to objects about structural entities to follow maybe in the future updates of the example. This one is from Sierra Soft, an Italian company for linear infrastructure. This one is a railway. They have done something a bit different than usual. They've used different colors for the alignment for when we are in a straight line using the blue color, and the red one for while we are in the curve for the turn, which is just a way for the vendor, for the producer of the data, to be a little bit more free about how such data is defined. But of course, they always follow the BSI structures and what the IFC5 expects. And this is another example, again from Sierra Soft, but this time from for a road. The model may seem similar to the previous one, but this one has also a little bridge part, but also a roundabout which is also something that in the previous version of the standard has always been interpreted in many different ways. So again, also thanks to Sierrasoft for bringing in such complex examples, because they are very complete. Then again, from buildingSMART, there is just the beginning of discussing about georeferencing. A lot of discussion is going on. So there is this file produced, a very simple one of as a lab, which has a point on it, which has a georeferencing coordinates. So what we do is we take these coordinates and we put this on our usBIM GeoTwin, which is our GIS integrated solution, just to see how it shows on a map. And so when you put on a map, you see that this is located at the Golden Bridge in Golden Gate Bridge in San Francisco. Even if it's just a simple slab, the point is that they wanted to show how to use reference points inside this new standard for geolocation. Again, a lot of discussion going on about it. But definitely something that will be clearly defined in the future version of the iteration of the standard. And this is another example, again, from buildingSMART International, which shows a cloud point that has also been integrated in the IFC5. And for doing this, the solution found is to use base64 encoding, which basically brings the cloud point data into the IFC file. Now, for this particular example, we, software vendor, don't really think that it is scalable enough. So before I said, okay, we bring in different standards like the PBR materials and so on. They are easier to reference because they are small insights. But take this example, we think that this is something that needs to be discussed, because if you want to bring in a cloud point of 100 gigabytes, probably the solution proposed will not work, will not scale. And anyway, there are probably better standards that have been talked specifically for point cloud, for optimization, compression, and so on. So definitely something technical that needs to be discussed and agreed clearly upon. But still, it shows the potential of the standard in doing such kind of things. Of course, going back to this, but also for the PBR materials, the data is there in the IFC5 models. Then the fact that one platform can read them and interpret them, for example, by showing the cloud point or by showing the PBR materials, this is something that then the vendors have to have support to such different standards, of course. In general, on
thank you, Michelangelo. Do we have any questions for Michelangelo before we let him go? I think we do.
Thank you for the presentation. My name is David Sweden, and how are you managing versions here on object level? Version.
Versions. Yes, there is a whole new kind of way of doing it compared to the previous version of the standard. Anyone can come in the new version of the data, which would say it's their opinion about the data, and based on where you put such opinion, if it's stronger or less strong than your previous opinion, your object will be the actual final data of the model or not. So yes, there is a versioning of object level, but it's in this new mechanism of
anyone can come with their opinion about the data for the object and overlay values.
But do you support the difference between design objects and individual instances in production? The architectural design is the requirement for the type, and then later on the construction, contractor will change to the real product into that window. The product owner will support those things and have possibility to relate them to have the shape.
Yes, this can be supported quite in an easy way. Each object has a part unit, which is a component when you put together the data from different resources. So even if you put one object, later on you can correlate it state, overlay the previous version of the object with the actual one. By refining it with this part in your data. So it's something that we should.
Because you want to have sensitive data with the individual room, for example, you want to trace it to a design room, but specific requirements from the unit or university. You can find that.
From my understanding, it should work because this room will be identified as one part, and everyone can attach information to it. So we'll be able to find the room itself with all of the user of all the user of data that had something to say about it. So I'm not probably understanding fully your use case, and probably it's also something that you may ask more to PSI technical team. But compared to the version, so easier to do something. Not sure if fully solves your use case.
I have asked this for 20 years.
I would then suggest you to ask, for example, to Leon to from his mark, but I'm more his reaction.
Thank you for those questions. The questions from the room. Good. Okay. You have the file as the file ready.
Yes, one of all, one of the example was the wall on the fire rating opinion about the value of the fire rating, and then there was another file which was saying that the fire rating was changing. So another one comes to play and say, okay, this is the actual value, overriding the values.
Yes. So kind of analyze that you get instead of having to use IFC model and just add an attribute. That's kind of
So it's more so there was the wall here with the fire rating. Other file with only the fire rating value. And when combining the two uses, you will then find the actual fire rating of the area. So you can use it for something for fuzzy that goes into your reaction.
Any other questions for Michael Angelo?
Last one, last one because I need to go down
Both your mind. Really quick one. Can we say we are now open USD compliant, or can we only say we are inspired by it?
I would say, last year for official development, but I would say it's fine, because in the beginning, we were much more creative. Now we are all in the concept. So you will see, the way the geometry is written, right, decided, define so geometry, let's say, refers to USD, which is universal picture, to the geometry function of it. So they are taking concepts, uh, complying with, but probably from a convention beyond that, but more and more we go forward, the more I think we are free.
All the advantages you mentioned about AI use is more on the JSON level.
Yeah, yeah, I mean, I study that in synchronization. There is probably also other way of synchronizing more efficient manner by an version of it, the format of a version of it. And this makes really appealing for the modern technologies to be integrated with much easier than the previous versions of Fusion.
Okay, that's great. Thanks very much. This ends the TD1 session. Thanks to Michelangelo.
Thank you.